Okay, so nitrogen trihydride, NH3, breaks down into nitrogen plus hydrogen. Now, nitrogen and hydrogen are both considered diatomics. So because they are diatomics, do you see the text now? Okay, since they're both diatomics, good, good to hear. Excellent. Just so because they are diatomics, we need to include a little 2 with them. Okay, there are 7 diatomics, and they are hydrogen. Let me change the color. The polyatomics are as follows. If you see hydrogen by itself, it's always H2. Nitrogen is always N2 when they're by themselves. When they're with another element, they're not diatomic. Oxygen is another one that doesn't appear. That's just O, it's O2. Chlorine, fluorine, bromine, and iodine. Okay, so those are the 7. If you look at the periodic table, the way I remember it is, so if you've got the periodic table handy, look at the periodic table, look at the 7th, right? Remember, there's 7 diatomic molecules. If you look at the 7th element on the periodic table, it's nitrogen. You can form a 7 from the 7th element, nitrogen, oxygen, fluorine, and then go down to chlorine, bromine, iodine. I think that's the order. And they form a 7, okay, from the 7th element, with the exception of hydrogen, which hydrogen is kind of on its own as number 1 on the periodic table. So that's a little trick. There are some others that people, have come together, like special mnemonic ways of remembering it. I don't know if your teachers had something about a Hofbrinkel or something like that. I don't quite know that one, but I remember it as, hey, it forms a 7 from the 7th element of the periodic table, and there are the 7 diatomics, with hydrogen being the 7th one. Okay, so that's my little trick. That's how I remember the polyatomics. Anyhow, when balancing, you write out your skeleton equation, okay? And then I like to separate my reactants from my products. So notice where the separation line occurs. Okay, so everything to the left are my reactants, everything to the right are my products. So what I'm going to do now is I'm going to list them. I've got nitrogen, I've got hydrogen. I try to list them in the exact same order as I wrote them. So if I write them in this order, on this side, here and here, I'm going to write them in that exact order, whether they appear in that order or not. It doesn't really matter. It just helps me line them up. I keep the nitrogens all in line. I keep the hydrogens all in line. It's easier visually for me to see that. Okay, anyhow. Now, let's count how many nitrogens we have. So on the reactant side, we have 1 nitrogen. On the product side, we have 2 nitrogens, which means, and this is one of the things that I do when I balance, I always put an arrow that goes up, showing me or telling me that I need to increase the number of that atom on that side. Okay, we can only increase, we don't decrease, we always increase. So the arrow goes there. Let's balance that, or let's look at the hydrogens. There are 3 hydrogens on the reactant side. There are 2 on the product side, which means I need to increase the side that is lowest. Okay, so the one I'm going to try to balance first is, I could try to balance my hydrogens, but if you look at hydrogens, I've got a 3 and a 2. We're going to want to look for common multiples, right, to get those, right? So we're not going to do that. We're going to balance the nitrogens first. Okay, so let me use a different color. So one thing to make note of, simple way to try to do stuff is, hey, why don't I put a little 2 there? You can never change the formulas. Okay, so we're going to undo that. Okay, you cannot change the formula. So the only place to change a number is to change the number in front of the entire compound. So right now, we were trying to balance the nitrogens. So the nitrogens now, I have 2 nitrogens So the count of nitrogens, 2. I no longer need to increase that. Understand that whatever numbers we put, sometimes we might have to change them. Okay, so understand that any number you put is not set in stone. It may need to be changed along the way. Anyhow, I put a 2 there. My nitrogen's balance. However, look at this now. That 2 gets multiplied with the H's. So now I have a total of 6 hydrogens. But it doesn't matter because I still need to increase the hydrogens on the other side. So right now there's a number in front of the hydrogen, and that number is a 1. That 1 doesn't work. So what number are we going to put? We are going to put a 3 there because 3 times the 2 will give me 6 hydrogens. Okay, so the balanced equation, so the skeleton equation is what I've written in black. When I add the numbers in front that I've written in with green, those are the coefficients that we use to balance it. So right now, this whole thing here is now considered our balanced chemical equation. One thing you're going to notice is we never put ones. Okay, so never, never, never put ones in the formulas. Okay. So any questions so far? That was pretty good, right? Pretty simple. Okay, it was one of the more simpler equations. So let's clear that. Let's see what we're going to do next. Let's see, are we going to do the next one? No, let's not do the next one. No, that one. Okay, by the way, this one here is actually already balanced. If you look at the answers to all these are in the slides, so feel free to go through the slides, try to balance them, and the answers are there as well. So let's is it this one? This is very similar to the other one. This is very similar to this one. However, let's do this one. This one's a little bit, this one has more elements to it to deal with. So we're going to balance this one just because it is a little more challenging. I think it balances very similarly to the previous one. Let's see, what's the next one? Actually, no, let's balance this one. Let's balance this one here. We're going to balance this one. Okay, so we have aluminum hydroxide reacts with carbonic acid to produce aluminum carbonate and water. Now, you need to know your polyatomics. So have your list of polyatomics to balance. Okay, so we're going to put together the formulas. So we've got Al OH3. Go back to chapter 4 to know how to put together these formulas. Okay, this is in the polyatomics. Plus carbonic acid we covered in 4.4. So carbonic acid is H2CO3, but because it's an acid, we are going to put the AQ. So this is the only time I want the state, because if we don't have the AQ, it's actually technically a different compound. Produces, to produce aluminum carbonate. So aluminum carbonate is 3 plus water, and water is H2O. Now, we're going to separate the reactants from our products. So let's list. So we've got now aluminum on this side, we've got aluminum on this side. Okay, I'm going to address the OH in a moment. So actually, let's address it now anyways. Remember when we, at the beginning of this chapter, when I asked you to count the elements? Here's the thing. I've got oxygen here and I've got oxygen here. I've got oxygen here, I've got oxygen here. When we balance, which oxygen are we going to balance? Okay, this is where the difficulties lie. So it's important to be able to identify your polyatomics, because you want to look to see, does the polyatomic appear on both sides? So here's an example. Carbonate, CO3, appears on both sides as CO3. So instead of separating the C's and the O's, we clump them together. So right now, let's count the carbonates. We have one carbonate on the reactant side, but we have 3 carbonates on the product side. So we want to increase the carbonates on the reactant side. Let's count the aluminums. We have 1 aluminum here. We've got 2 aluminums here, which means I've got to increase the aluminums. Now, and one of the reasons why I share this one is because there's a little trick to balancing these types of reactions. Okay, and here's the trick. Notice how I have hydroxide and hydroxide together. It would be easier to balance than if I have to separate them. But we want to look for the hydroxide on both sides. Hydroxide doesn't directly appear as hydroxide on both sides. So the trick is this. What you want to look for is that if you have hydroxide on one side, look for water on the other. Because another way to write water, and I'm going to erase this water because I'm going to write it in a different way to help me with the balancing. And I'm going to write water as HOH. So this, let's see if I can erase this without making a mess. There we go. So technically this OH, this OH that we have here is technically, I've got 10 minutes left in this lesson, is technically this OH on this side. Okay, so I'm going to wrap up the lesson with this example here. Okay, so with this sample problem. So there's the OH. Okay, so let's continue with listing. Okay, so that's the trick. If you have OH on one side, look for water on the other and rewrite water as HOH because it'll help you with balancing. So how many OHs do we have here on this side? We've got 3 OHs on the reactant side. We have 1 OH on the product side. And then our hydrogen here, this hydrogen is to be balanced with that hydrogen. So on this side, we have 2 hydrogens. On the other side, we have 1 hydrogen. Notice the order that we list them, okay, the order that I list them here doesn't matter as long as I list them on both sides in that same order. Anyhow, let's see where the counts are. So we need to increase this and we need to increase that. So the rule of thumb is this: when we're balancing, whenever we have a polyatomic, we want to balance the polyatomic first. So let's balance the carbonate first. So the 1 isn't going to work here. So what, or the 1 here isn't going to work. So the 1, we're going to put a 3 because now our carbonate count is going to go up to 3. But what else changes? Our hydrogen count will change to 6, but that's okay because I still need to increase the hydrogens on this side. The next polyatomic, again, we stick to the same rule of thumb, polyatomics first. So we're going to balance the hydroxides. So we're going to put a 3 here in front. We have now 3 hydroxides and we have 3 hydrogens, which means we don't need to increase the hydroxides, but I still need to increase the hydrogens, but that's okay. So what are we going to balance next? Well, there are no more polyatomics. So the only things that are left to balance is aluminum and hydrogen. Okay, so what we're going to do, we're going to balance the aluminums next, because the aluminums now are going to change the hydroxide count. The hydroxides are balanced if you look at them, 3 and 3. But I need to balance my aluminum, right? And that's going to change my hydroxide. So instead of changing this hydrogen right now, let's change the aluminums, because, well, it's going to change the hydroxides anyways. So we're going to put a 2 there. So now I have 2 aluminum. I don't have to balance my aluminums, but I now have 6 hydroxides, which means now I got to go back to increasing the hydroxides. So right now, this 3 isn't working. Okay, so let's get rid of that. So if 3 doesn't work, right? What if 3 doesn't work? What number do I need to put? And that number, remember how I said before, the numbers aren't set in stone. We had a 3 originally there, but it doesn't mean that I can't change it if it doesn't work out with my balancing. Okay, so in the end, now I have my 6s. Okay, so I have 6 hydroxides, I have 6 hydrogens. So in total now, hydroxides, hydrogens are balanced, carbonates are balanced, aluminums are balanced. So there is my balanced chemical equation. 2 aluminum hydroxides plus 3 carbonic acids to produce 1 aluminum carbonate and 6 water molecules. So this rule of thumb here, like I said, look for water whenever we have a hydroxide on the other side. So that's a little trick. In terms of balancing the other sample problems, they're really not much different to that rule. When dealing with polyatomics, balancing becomes so much simpler because you're not separating every single element. You're actually combining the elements. And that's why I like you doing sample problems with polyatomics, just so people can see when you're balancing how easy balancing can be when these polyatomics are actually there. Okay, I'm gonna end it there for tonight, but I will be taking any questions. Are there any questions for any of you that are out there right now watching? Um, any questions? So if there aren't any questions, we will reconvene again on Wednesday. We are going to look at at types of reactions. So we're going to go through all the types of reactions. I'm going to try to simplify the types of reactions chapters, so it won't cover. We're not going to cover all the different rules of the types of reactions that I have in there. So so important that when you kind of follow along, so this way you know exactly what types of reactions we're going to ignore and what types of reaction, or we're not going to ignore, but some of the little technical rules within each one of those chapters. So we're going to try to cover it very similarly to what was covered at the grade 10 level in terms of balancing, in terms of the types of reactions. Okay, so we're not going to look at all the little I guess specialty types of reactions. So we're still going to cover things like synthesis, decomposition, single displacement, double displacement, neutralization, complete and incomplete combustion reactions. So we are going to be covering those. But when you look at things like synthesis and decomposition, they do have some special rules within them, and we're going to try to eliminate some of those just to kind of help alleviate some of the stresses that we might have with regards to this course, and trying to cover as much as we can, but still kind of puts ample relevance to the material. Okay, so if there aren't any questions, um, like I said, I guess, if you know anyone in the class, let them know. They can find the Zoom videos on YouTube, and kind of follow along. But I do recommend letting them know. Don't just rely on the videos, because technically there are other people who put together the videos, their own videos. I've got my own, as you'll see on my channel, but this way you actually get some one-on-one time, and you can ask questions and stop me along the way, and this way I can kind of address it. So please do stay tuned, do show up to class. But other than that, everyone, you're very welcome. Have yourselves a wonderful evening, and hang in there. We're all in this together. We'll do fine. Okay, take care, everyone. Bye now. I'll see you guys all Wednesday. I hope you liked this video. If you did, do not be shy to hit that thumbs up button. And while you're clicking the thumbs up, click on that subscribe to stay tuned to my new videos. Thanks for watching.